As I was saying, the plan for today is I'll be sharing some 12 questions on quant and data sufficiency. Four of them are on DS, and the remaining are quant questions. They will be on different areas of the quantitative section, but primarily focused on arithmetic and number properties. Okay. I'll basically check how you are approaching those questions. So you will be given like 2-3 minutes to try them out. Once that's done, then I will solve it, and then we can exchange ideas like how you could have done better or what could be a better way of solving. Okay. So we'll start off. I think we can start now. Yeah, you can see the screen, right? This is the first one. Can you all see the question?
Yes.
Okay. All right. I'll keep a track of the time so we can start. In the meanwhile, if you any one of you get the answer, you can just put it in the chat, or you can just let me know. Yep. Anyone got the answer?
Yes, I think it's D.
3:5. Okay. All right. What did you do?
Yeah, so I just wrote it out first. So I said it was 5:7 and 1:3. So then
Okay.
I added. I said 5 plus 1 is 6, and 7 plus 3 is 10. So my ratio was 6/10,
Okay.
and that simplifies to 3/5.
Okay. So if I ask you like, why did you add? Why did you think like you could add?
Yeah. So I was thinking because it's asking if these two hours are mixed. So I'm thinking mixed means that we would add. I'm
Okay.
not
All
exactly
right.
sure, but I'm thinking maybe we just add the 5 and
All
the
right.
1 because that's the iron, and then copper is 7 plus 3.
All right. Okay. So I'll just explain the concept once. So let me just open a different tab. Yes. Can you still see this one?
Hmm.
The paint file. I've just opened the paint file.
Yes.
All right. So now if you look at the data, the question is saying, 1 minute. Yeah. So it was iron and copper in the ratio 5:7, right? So 1 second. Okay, I can't seem to annotate what's wrong in this. Mhm. Okay, now it's so the iron and copper is 5:7, and in the second one it is 1:3. You can see what I'm writing, right? I'm annotating here 5713. I've written. Is that visible?
Yeah.
Yeah. Okay. Now see, when we are writing ratios, so this 5:7 and 1:3 are two different ratios, right? Right now these two are not linked to each other. This 5 and 7, this 1 and 3 are not linked to each other. So when you think of ratios, always think of a constant that is multiplied to these values. For example, 5 and 7 could have been 50 and 70. Okay. 1 and 3 could have been 2 and 6. So we don't know what is the multiplier in the ratios. So when you have this 5 and 7, you have to think it is 5x and 7x. But when you are doing 1 and 3, you must take a different variable y and 3y. The moment you think of this, you will understand that 5x and y now cannot be added. So that was your mistake. You added 5 and 1, right? You imagined or assumed that the multiplier is equal in both cases. That was the first mistake. So to avoid it, take different variables straight away in the beginning, x, x, y, y, okay? Now see what the question is saying. The question then says that the two alloys are mixed in equal quantities. So now, if the two alloys were mixed in equal quantities, so this 5x and 7x, what is the total quantity of this? Can I say it is 12x? The total quantity of this? Whereas for the second one, it is 4y. Till here, is it okay, everyone? 12x and 4y? We just added iron and copper in the first alloy, and in the second alloy, we got 12x. Let's say these are all kilograms, okay, or these are all pounds or whatever, okay. The second one also 4y kilograms. According to this question, now this and this should be equal. So let us set up 4y equals 12x. We'll replace the y with 3x. Why was this necessary? Because as I said initially, these two ratios are not linked to each other. Not linked means they have different variables. So our target should be to first get them having the same variable. Now that we have done that, y in terms of x, so we can get rid of this y and replace it with 3x. And we can get rid of this 3y and replace it with 9x. This will then become 12x. Now their quantities are equal. And now you can add them because both are in x terms, so you can add them. So how much iron do you have? So finally the question, iron and copper, 5x, 3x. So that's 8x. And 7x, 9x, that's 16x. So the ratio is 1:2. See, did this make sense?
Yes, I got that. Just a quick question. So I
Yeah.
understand how you got the 12x and the 4y. So I get the 4y equals 12x, but how did you know that the y equals 3x?
Oh, divide both sides by 4. It's 4 multiplied with y that equals 12 multiplied with x, right? Now you want to divide both sides by 4. So you will get y equals 12 over 4. That's 3 times x.
So you divided the 12x divided by 4?
Yeah, I divided both sides by 4. So from here, you divide by
Oh, I
4
see.
both
Right,
sides.
right. That makes
4y
sense.
over
Yes,
4,
yes.
and 12x over 4. Okay, that gives you this.
Okay, I see. Yes, that makes sense. Thank you.
Okay. All right. Let's now. Anyone has any other questions from this?
So the final answer was 1/2, right?
Yeah, yeah. 1/2.
Okay, got it. Thanks.
Okay. All
Um, is
right.
there is there a faster way to approach this problem instead of
Yeah.
just like
See. Yeah. So this was I was explaining the basic idea. So when you actually go on to do, like if you have done enough practice, then all of this is not necessary. Okay. So you start off with 5, 7, 1, 3. Don't add. Okay. The first thing is understand why we can't add. So to explain that, I use all these variables. Okay. So now what you simply do is find out the total. Why are we finding the total in the first place? Because the question says that the total must have been equal. They are mixing equal quantities. So we are finding the total of the first alloy. This is A1 and this is the second alloy A2. One is 12, the other is 4. Now we realize that they are not of the same quantity, so we need to make them equal. How do we do it? We multiply the second one with 3 because 4 3s are 12. If I do that, then this 3 becomes 9 and this 1 becomes 3. Now it's done. You add 5 plus 3, 8, 7 plus 9, 16. So 1 is to 2. Or, okay. The method that we discussed in the previous method is the same thing what we are doing now as well. Only that time I was showing you with all the variables and all with the x, y, so that you understand the logic behind it, why we are doing it like this. So now this is the actual implication, like this is how you will actually execute it. You don't have to do all those variables. But initially, while you are practicing and solving, I would suggest keep those x in mind, x, y in mind, and so that it becomes very clear that what is correct and what is not correct. And once you get the hang of it, then you drop those variables and work it out like this. Fair enough. Does this answer your question?
yeah, got it. Thank you.
Okay. All right, then let's move on to the next. I'll just share a new file. All right, let's try this one. Yep. Anyone with the answer? No? 1 kilometer, okay. Someone's not, that's not right. Okay. So what's the approach method? How did you approach this? Did you, so what are the speeds? Did you figure out the speeds? Yeah, okay. 1.2 is good. Okay. 1.2 is the correct one. Anay, right? I think you answered it. Good job. So how did you solve it? Did you figure out what the speeds are and then set up equations and stuff? Okay, we're thinking C and D, all right. Maybe, okay. So was it equation based approach or did you try with ratios and all?
Hi, Sujoy.
Yeah, hi.
Actually, I tried it with equations based, so I found out John's and
Okay.
David's speed first,
Fine, fine.
and
I got
then
it.
I took the length of the race as d meters, and
Correct.
since we are told that David finishes the race first, we
Got
can
it.
set up
Got it.
like an equation on the base of
Yeah, yeah.
d. Yeah.
Perfect. Perfect. Yeah, okay. So that's the normal way of solving it. Okay. See, the point is, if you, yeah, okay, if you realize that 20 minutes for every kilometer, that's not the speed, right? Because speed is kilometer, I mean, distance per time. Here they have given time per distance. Okay. So 20 is not the speed. 20 is minutes per kilometer, whereas speed is usually we keep units as kilometers per minute or kilometers per hour or meters per second and all. So since it is not given in that format, we can always figure out what the speeds are first and then set up equations and stuff. But what could be a faster way? Let's see. So I'll just share 1 minute. Yeah. So this is much better. So now see, it says that John takes 20 minutes to walk 1 kilometer. So John takes 20 minutes and David takes 16 minutes to walk that same kilometer, right? Now it says that in the race, David beats John by 240 meters. Now, what do you make out of this? So there is a race. David, who is the faster, obviously, because he takes fewer number of minutes to cover the same distance of 1 kilometer. So David finishes first, while John is behind him, and their gap is 240 meters. Is everyone okay with this?
Yeah.
Now, this is what is it's mentioned. Now, what can you say about the time they have taken to come to this scenario? Like they all started from the same position, J and D, together. Finally, they ended up here. What can you say about the time they have taken? Did they take equal amounts of time? Did they take different amounts of time? Can you say anything about this? It's the same amount of time, right? Like when they finish the race, D is here, J is here. That means what? Whatever the time is, maybe 1 hour, maybe 10 minutes, maybe 30 minutes. I don't know what the time is, but I know for sure that both of them traveled for the same amount of time. And D is finishing the race at this point, and J is 240 meters behind. Is that fine? That's what logically is, right? That's how you measure the distance, how far behind you are. So, same time. Now, here you see the time is not the same. Okay, here when they gave you the data, they gave you 20 minutes for 1 kilometer, 16 minutes for 1 kilometer. Let us take the multiple of 20 and 16. What is the common multiple of this 20 and 16? Anyone? The least common multiple of 20 and 16?
Should be 80.
80. So to get to 80 minutes, I multiply this with 4 and I would multiply this with 5. Okay. Understand, this is for 1 kilometer for D and this is 1 kilometer for J. Okay. So in 20 minutes, if you travel 1 kilometer, in 80 minutes you would travel 4 kilometers. Is that okay? And this other guy D, in 16 minutes if you travel 1 kilometer, 5 times if you do, in 80 minutes you will travel 5 kilometers. Is that fine, everyone?
Mhm.
All right. Now comes the very interesting part. See, what we now have concluded is if the time were same, now what is 80 minutes or not, I am not really interested. Okay. If the time were same, then D covers 5 kilometers and J covers 1 kilometer. Am I right? 4 kilometers. Am I right? In the same time. In the same time. Is that okay? In the same time. Why am I so focused on the same time? Because in the actual race, the time was same. In the same time. Okay. Here also it was same time. So that is why I'm trying to figure out what happens if the same amount of time was given. So D covers 5 kilometers, J covers 1 kilometer. How much does he lose by 1 kilometer? Am I right? So can I say that if there was a 5-kilometer race, so in a 5-kilometer race, this guy would have lost by J lost by 1 kilometer. Would that be a correct statement? If it was a 5-kilometer race? Okay, J will lose by 1 kilometer in a 5-kilometer race. How much did he lose by here? 240 meters. So this should be how much? 1200 meters. So the answer is what? Is it okay? What I did here was just figure out in the same time how much distance they covered. What is the ratio of the distances? That's it. Why did I do that in the same time? Because in the actual race, the data that is given for 240 meters, that happened in the same time. So this 80 minutes thing is not important, that how much time, because the question is not asking you how much time it took. So this is 80 minutes, that's okay. But my focus is not on that. My focus is on 4 and 5. So that means when D covers 5 kilometers, J will cover 4 kilometers. Both taking 80 minutes in the process. That is okay. That is not important. That's not what the question is focusing on. What is it focusing on? 5 and 4. So the difference is 1. So that means if it were a 5-kilometer race, this guy would lose by 1 kilometer. So if he has lost by 240 meters, then the race must have been 5 times as large. That's it. So 5 times of 240 is 1200 meters. That is 1.2 kilometers. So this is the easy way of solving this without going into equations, just working with the ratio. Did that make sense? Is it okay? Something that you got it? Or if you have any difficulty in understanding, please tell me. Yeah, Nai, tell me.
So does that mean the race was actually 6.2 or it was just 1.2 the race?
Okay, I'll just redo this. I guess this was a little confusing. Okay. I'm redoing this, okay? All right. So for the same distance, equal distance, okay? When it's the equal distance, time taken by John and time taken by David is in the ratio 20 to 16, which is 5:4. Is that okay?
Yeah.
Okay. Now, I don't want equal distance, right? What happened in the race? In the race, they traveled for equal time. So when I'm saying, so distance and time, okay, that's what we are trying to link. So now when I'm saying that if both had to travel equal distances, their time would be in the ratio 5:4. Okay. So if I now change the condition that no, I don't want equal distances, I want equal time, then what will be the distances covered by D and J? The D, this D stands for distance. Let's put it like that. Distance of J and distance of D. What will be the distance ratio? Whoever is taking more time here, like J is taking more time, right? 5 would end up covering less distance, right? If this
Yeah,
fellow is taking more time, means he's slower. If he's slower, then given the same amount of time, then the J would cover a fewer kilometers than D would be. So their ratio will now reverse to 4 by 5.
correct. Yeah,
If this is 4 by 5, that means what? In the actual race, which was, let's say, of 5 kilometers, if it were 5 kilometers, D will finish it. J will be covering only 4 kilometers and lose it by 1 kilometer. This is what it means. 5, 4,
yeah.
and gap is 1. In the given scenario, it is said that the gap is 240 meters. So if this is 1, this is 5. That's what the idea is, right? So if this is 240, then it will be 5 times. So this would be 1200.
Okay, got it. Okay, yeah.
So D covered 1200, J covered 240, less than that. That would be actually 960. Not interested in that. We just need to know what is the total length of the race. 1200 meters.
Got it. Yeah.
So that's what I was saying, that see, this you might not get it in one shot, okay? This ratio thing. So I was saying, okay, this guy is taking 20 minutes, 1 kilometer. This is J, and for D it is 16 minutes for 1 kilometer. So if I were to make them equal to 80-80, then this would become 4 kilometers. This would become 5 kilometers. That means if I give you equal amount of time, then J will cover 4 when D covers 5. This is what I was trying to arrive at without using this ratio form. This ratio sometimes can be a little confusing. So I said that, okay, let's just assume some equal amount of time instead, and we'll work out from there. Now, once 4 and 5 is there, now we come to this diagram. This is what the diagram means for 4 and 5. From there, we conclude this. That if the gap were 1 instead of 240 instead of 1, then it would be 5 times as large.
So Sujoy, just a bit confused. I got what you were saying, but when I think it's confusing how they use two different conversions. So they talk about kilometers and then the meters. So yeah, I'm not sure how to convert.
See, it would not matter because you changed the units. You're talking of units, right? Kilometers to meters. I changed the units and I am not factoring that in.
Okay.
Yeah, that's what your question was, right? Like, how can I just work with kilometers here and then again work with meters here? Was that your question, right?
Right.
Yeah, see, what I'm trying to say here is that I just took some units here because I am saying that this part you understood, 4 kilometers and 5 kilometers, which I was saying.
Mm-hmm.
So 4 kilometers, 5 kilometers could also mean that this is 4,000 meters and that's 5,000 meters, right?
Okay, right.
Yeah. So if I convert to meters, now see what is happening. Let's change it. Okay, so this is 5,000, this is 4,000, this is 1,000. So my question to you is, if 1,000 becomes 240, yeah, that's the scenario, right? 1,000 meters has become 240 meters. What will 5,000 meters become? How would you find that? 240 upon 1,000 multiplied with 5,000, right?
Okay, right.
The zeros will anyways cancel out, right?
Mm-hmm.
You will get back 1,200 only. So that's why I was not bothered to change it, because I knew that eventually that would anyways have cancelled out.
I see. Okay, got it. That's very helpful. Thank you.
Because this 4 and 5 is more in a ratio form I'm thinking of. Okay, if this is 4, then this is 5. Now that could be 4 meters, 5 meters, or it could be 4 kilometers, 5 kilometers. So if you want to stick to units, that's fine. You can just change it to 5,000, 1,000, and 4,000, and then just do this one extra step. That 1,000 becoming 240 is a 5,000 is what? It's just 5 times. So 240 times 5, 1,200. Okay, so there is no change in this answer because that 1,000 multiplier effect that we have from converting units will actually cancel out in the 5,000 and 1,000 here. Now is that okay? Anyone has any other questions on this? My suggestion is when you are solving questions on time and distance, especially these type of questions, try to, when you are solving, practice, when you are practicing, right? So try to use ratios rather than forming equations. Okay, the more you can work with ratios, the faster your solutions will come out to be. I'm sure those who tried out with equations, it would have taken a lot of time to set up the equation first. Setting up becomes a little challenging sometimes, okay, and then we have to again solve it. But if you are clear with your concepts in ratios, then you will find that questions can be solved much faster, especially in this arithmetic part. Okay. All right. Let us now, I think we can move on to another one. There are quite a few to discuss. Yeah. Next one. So this is actual official guide question. Anyone recognizes this? 30 numbers, then you scale it up and then scale it down and all that. This is a question from the official guide. Okay, so you don't recognize, that's fine. So you can try doing this. Then we'll discuss. Stump term calculation. Okay. There isn't a lot of calculation actually. Let's see. Yeah, we are anyways spent 2 minutes on this. So let's look at the working on this. Okay. Yeah. Okay. So a few important points. What are the important things here that we observe? 30 numbers. None are integers. None of which is an integer. All have decimal points. Okay. And their sum is s. Actually, if you end up adding everything, you'll get s. Okay. Now they have done something different. They have done the estimated sum, which they have defined as follows. So if the tenth digit means something decimal, whatever comes here, that's the 10th. Okay, that's the 10th digit, this one. So if the 10th digit is even, so it could be 2, 4, 6, 8, can't be 0. Okay, even, then it is rounded up, increase the number. So if it is x 0.246 or 8, it will now become x plus 1. That's what it's saying. Okay, round up to the next integer. And the 10th digit is odd. So if it were y.1357 or 9, then you round it down to the nearest integer. So it will then just become y. That's what is happening. I guess this was clear. It's very lengthy language. Okay, so you have to like read it very slowly and then make sure that you understand. Now it's saying 1/3 of the number. So there are 30, 1/3 is 10. 10 have an even digit. So this is there 10 times. And this happened 20 times. So they are saying what could be e minus s. So what is this e? After changing the numbers that you get here, if you add them up, this sum, that is e. Whereas the actual sum that you have here, that sum is actually s. You have been asked to find the difference between e and s. Okay. Now, obviously, the moment you see something like this, you realize that you can't calculate e minus s. I mean, you can't simply, because there can be so many possible scenarios. Okay. How much are you increasing? That depends on what digits have been there. You have not been mentioned anything of that sort. So what you can only figure out for these sort of cases is what can be the range of values of the difference. So that means we want to find the e minus s maximum value and e minus s the minimum value. Okay. If we can figure these out, we have to check which of these falls within that range, and accordingly we'll mark that these are possible, the others are not possible. Okay, that will be the strategy. So now let us look at this. How do we find out e minus s maximum? E is, remember, this is e, the estimate, not the actual. Okay, e is the estimate. So how do we find out e minus s maximum? For this to happen, rounding up should happen more, rounding down should happen fewer number of times, or not fewer number of times, but a lower quantity. So to maximize this, what we will do is we'll round up by a big amount. So rounding up will happen by a big amount if we round up from 0.2 to the next number. So rounding up will happen by a value of equal to 0.8. 0.8 will be the round up. How many times? 10 times. So that means there will be a total increase here, an increase of 8 marks or 8 numbers, 8 values. Till here it's fine. Because if you have something like 1.2 and you round it up to 2, so you have increased by 0.8. That's the maximum it can go up by, because 2 is the least it could have been in the 10th place. So maximum increase is 8 and you have to do it 10 times. So maximum it can increase by 0.8 times 10. So 8. But then these will also get rounded down. So they will become smaller. So the value by which they become small, we have to make it very little, small, minuscule, negligible. So what do? We'll assume that the values were 0.1. So 0.1 decreases. So 1.1 becomes 1. So the decrease is just 0.1. So increase is this much. Decrease is 0.1. But how many times? 20 times. So that means decrease is 2. So that means you will have a net of 8 minus 2, 6 difference in the estimated sum versus the actual sum S. So that means E minus S maximum could be 6. Maximum E minus S is 6. Everyone please check whether this made sense till here. Anyone has any doubts? Because if this is clear, then the next part is very easy. You have to just do the minimum, just the reverse of this. So now what will be the reverse? We will increase very little. So we'll increase from 0.8 to the next number. So increase will be 0.2 times 10. And we'll reduce by a large quantity. We'll reduce from 0.9 all the way till 0. So that means reduction will be 0.9 and that will be 20 times. So that means 2 minus 18. So there will be minus 16. So that means the minimum value of E minus S is negative 16. So our answer of E minus S has to fall in between these two values. You have both of them. 10 falls beyond this, not possible. So answer is 1 and 2. Okay. So these sort of questions where everything is kind of unknown, right? And yet you have to choose a set of possibilities. Okay. Whenever you see this possible value, okay, try to think in terms of what could be the largest possible value and the least possible value, and if your option or choices falls within that range or not. That is the idea. Everyone, please go through this. Tell me if you have any questions.
Yeah, do you mind just going over what the difference between an integer and a whole number is?
Oh, there is no difference. Whole number starts from 0 and goes on till positive numbers only. While integers can be positive, negative, anything without any decimals.
So they're the same thing, whole number and integer?
No. They are not the same. This is the set of integers. And this is whole numbers. Whole numbers 0, 1, 2, 3, dot, dot, dot. While integers, the other numbers are there, -1, -2, -3, till negative infinity.
Oh, a whole number is only a positive number.
No, only non-negative numbers. 0 is not positive.
Oh, okay. But for an integer can be 0, right?
Integer can be 0 also, negative also, positive also.
Oh, so an integer is anything really, just no decimal.
Anything without any decimal.
I see.
Without
Okay.
having anything after the decimal. Whole numbers
Got
are
it.
non-negative integers.
Okay, that's helpful. Thank you.
But on the GMAT, they don't usually use these terminologies of whole numbers or natural numbers. They specifically use non-negative integers, negative integers, non-positive integers, positive integers, or just integers.
Okay, got it. And you mentioned the natural integer. I know you said it won't be on the test probably, but yeah, what is a natural?
Yeah. Those are like terminologies which on the GMAT they don't use. Natural numbers are basically a part of these whole numbers which start from 1. Natural numbers are this 1 onwards.
Oh, I see. Okay, got it. Thank you.
Yes. Any other questions?
Yeah. Also, so for the x plus 1, that was because you rounded up. But for the y, how come it's not y minus 1?
No. It's not minus. Say 1.5 will become 1, right?
1.
So y point something will remain y. It will not become reduced to the previous integer, no?
Okay.
So
So
say for example, if you had 3.2, it will become 4.
Mm-hmm.
That's okay. But if you had 5.7, it will just become 5. It will not become 4, right?
Oh, I see. Okay. Right. Got it.
Okay. All right, then we'll move on to the next one. I'll just share the next question. Yeah, this is a hard question. All right. Anyone getting the answer to this? C. Okay. C is 1 and 2. Yeah. Good. Nice. Well done. So did you take examples?
Yeah, I picked examples of like 2 square, 7 square, and 6 square.
Good. Nice. So that's actually a good way of tackling questions. So when you get stuck somewhere and like logically, or you cannot come out with proper conceptual solutions to it, best way is pick some numbers, see how the pattern is working. If it works consistently for quite a few number of times, just go ahead and mark it. Okay. So you can see my screen, right? What I'm sharing here. Yeah, I guess so. Yeah. Okay. So here this talks about a positive number which is also a perfect square. So we pick some perfect squares. So small numbers, like we can pick 4, 9, 16, maybe a 36, and just check. It talks about first statement, the number of distinct factors is odd. Okay. What are the factors of 4? It doesn't talk about prime factors. It just talks about distinct factors. So let's write down the factors of 4. So we have 1, 2, and 4. All right, 3 of them. Let's try with 9. 1, 3, 9. Okay. three of them. Odd in each case. It's focus on the odd. 16, 1, 2, 4, 8, 16. Okay, we have 5. So that's odd. 36. All right, so long one. 1, think of the other end. 1 times 36 will be 36, right? So write 36, okay? This way, if you do it, good thing is you don't have to like keep on writing everything till the end. So you keep on matching. Then 2, 2 times 18, okay? So 3, 3 times 12, all right? 4, 4 times 9, all right? And then 6, 6 times 6 itself. Okay, how many did we get? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it's always coming odd. Safe to bet that 1 is true. Okay, till here everyone is fine, I guess. I just listed down some perfect squares. Then we listed down the factors of those perfect squares, and we found that every time it's coming out to be odd. Then
Yeah,
number
just a
2.
quick question. When it
Yes,
says distinct factors, what's the word distinct mean? Like, what if it just
different,
said
different,
factors?
different.
Oh, different. Okay, got it.
Yeah. Next is saying some of the distinct factors. So whatever factors we have listed down, good thing that we listed down because now we have to actually add them up and check. So we add them up. Here 4, 5, 6, 1, 7. Okay, it's 7. 9, 10, 13. Okay. 16 plus 8 plus 4 plus 2 would be even, whatever that even number is. And then there is a 1. So it is going to be odd. No need to calculate. Okay. Here again, even, and even. So all of these add up to an even number plus the 9 makes it odd because 9 is odd. Okay, I'm not wasting time in actually calculating. That's unnecessary. You just need to check even or odd. So till 9 we have used odd. That odd number plus another odd number 3 will make it even. But that even plus that last one, which is an odd, will now again make it odd. So all of them have come up to be odd. So 2. Number 3, the number of distinct prime factors. Now this time is talking about prime factors of n. Here there is only one prime factor, which is 2. It's odd. Okay. Here also odd. That's okay. Here 16. It's only 2. Prime factor is only 2. Okay. Prime number. Okay. Prime factor means a factor that is a prime number. Okay. But 36 is 2 and 3. Even. Does not hold. 3 is out. So 1 and 2. You are done. Okay. We are done for this question. We know how to solve it. So what's the method? See, when you get stuck, pick numbers. Okay. That's the good thing about the GMAT. The answer choices are already given to you. You don't have to write an answer by yourself. So if you choose numbers, you just have to check which of those conforms to the options given in front of you. You just have to mark an option. Okay. Now, if you are interested in figuring out why this is the case, okay, then I can give you an explanation for this. There is a proper explanation for this, okay, which you actually would be necessary. Like GMAT, you have higher difficulty level questions also, right? So there could be questions where they actually test you on that knowledge. Okay. So I'll just quickly go through that small thing as a, I can't discuss the entire thing because we don't have so much time, but I can just give you a brief. So if I get any number n and express it in its prime form, so like a to the power x, b to the power y, like that, c raised to the power z, and so on. What are these? A, B, C, etc. are prime factors of n. Okay, they are prime factors of n. Then the number of factors is given by this. This is a useful relation. You can remember this. You have to just add 1 to the exponents that you have multiplied out. Now, where does this come from? So I usually discuss all of this in my lessons. So as I told you, like we don't have so much time to discuss the entire thing. So this is how it comes. I mean, this is the final result. How it comes from, like you can, if you want, you can attend one of my lessons on number properties. I'll discuss that. A free event is coming up in a few days. You can register for that also. Okay, I'll discuss that over there. So just to give you an idea that this works, if you look at 36, so 36, if you factorize it in terms of its primes, that's 2 squared times 3 squared. Okay, this 2 squared is 4, 3 squared is 9. Look at the exponents, 2 and 2, add 1 to each of them. 3 times 3, you get 9. You count here 1, 2, 3, 4, 5, 6, 7, 8, 9. There were 9 factors. Okay, that's number one. Number two comes the question of the sum of the distinct factors of n is odd. Why will that happen? Now let's understand something. If you have, let's say, 5 odd numbers, just saying 5 odd numbers, the sum is odd, right? 3 odd numbers, the sum is still odd. 7 odd numbers, it's still odd. So if you have an odd number of odd numbers, okay, understand what I'm saying? Odd number of odd numbers, the sum will always be odd. So if I have a perfect square which is only an odd number, say 749, 7 square, it will have an odd number of factors. Since the number is odd, all its factors will be odd. So sum of an odd number of odd factors, the sum must be odd as well. Everyone fine? So that is why you see for 9, 1, 3, 9, it is coming out to be an odd number. Now the question you might ask me is, that you should ask me is, that okay, you explained it for an odd number, but what if the number is a perfect square which is an even number? So let's take 16. Now why is it that for 16 we have the sum still as odd? Why doesn't it become even? Now it's very easy to understand that all the factors will always be even except for the 1, and therefore all these even numbers plus the 1 will make it odd. So the sum has to be odd. Okay. For 36, what is happening? Because it has some odd factors and some even factors also. So for that, I have to here discuss about how to calculate the number of even factors, and then from there on build on it. Okay. So it won't be sufficient time to explain that in that detail. But it can be proved that for any perfect square, so this is actually a very important result to remember. For any perfect square, point number 1, the number of factors must be odd, and number 2, the sum of the factors must be odd. And that's true for perfect squares. Is that okay? Yeah, Anay, so you asked me, like, when you mentioned hard, why was it so conceptually? Yes, that's the idea, that you can easily solve it. For this particular question, you can solve it without understanding the concept in much detail, because you can just pick numbers and work it out. But there can be a harder variant of the same question where the concept becomes very important. Okay, so that is why. So like I could have said that which of the following can be the sum of the factors of a perfect square, and I give you 5 options, of which only one of them is an odd number, the others are all even numbers. So if you don't know this idea that the sum of the factors has to be an odd number, you wouldn't have been able to solve that in that case, isn't it? So conceptually, it's a very important or difficult idea to understand. That is why I mentioned it's a difficult question. Otherwise, for this particular question, your easy way of working it out would be to pick some numbers and get the answer. Right? Everyone clear with this? Anyone has any questions? So this can be an important thing to remember. So we are already we have already exceeded the time. What I'll do is, see, I'll just share with you the remaining questions, so you can maybe take screenshots of those, and you can get back to me with the answers if you want. You know my I have already messaged you today only before the lesson that we are starting, so you can just reply to that message on Leland itself. So I'll get your messages and I'll reply back. Okay, if you are correct, or if you are not correct, then what should be the correct answer? So let me just share the questions. Yeah, so we did this one. Okay, this one next. You can take screenshots. Done, I hope. I'll move to the next one. The answer is E for that. This is a combinatorics question, permutation combination. Easy level, not very difficult. Okay, I'll move on. This one also is a very good question on permutation combination, counting. And these are the data sufficiency ones.